In this class, now I am going to explain you the complete concept of addition of vectors. So first let us learn the definition of a vector. You have learnt this definition of a vector in the physics as a physical quantity having magnitude and direction is known as a vector. But when you come to the mathematics, here you have to define this vector as it is a directed line segment. We have to define in the mathematics, it is a directed line segment. I hope you have understood the definition of a vector in the mathematics. Now let us know the meaning of a scalar. Scalar is also a physical quantity having only magnitude but not having direction. Scalar will get only magnitude but doesn't have direction. Remember this point. Now let us fix O is a one point at the origin. See, let us assume this 3D like this. So this is origin. Fix a point O at the origin and consider a point P in the space. This OP is called position vector of P with respect to O. OP is called position vector of a point P with respect to this origin. You can take this OP as R. OP is equal to R. I hope you have got the meaning of position vector of P with respect to origin. So it is on vector directed line segment O to P. Right? Now let us learn the meaning of a zero vector. Zero vector, or you can also call it as a null vector. A vector having its magnitude as 0 is known as a null vector, or you can call it as zero vector. If the magnitude of a vector is 0, then such vector is known as null vector. And for this null vector, initial point and terminating point both will be same, and whose direction is arbitrary. Okay, so the direction can be any way. I think you have got it, the meaning of zero vectors. Zero vector. Now let us go to the proper vector. A vector, a non-zero vector is known as a proper vector. How you have to define a proper vector? A non-zero vector is known as a proper vector. If you find the magnitude of that vector, that must be positive. Okay? Now let us go to learn a unit vector. Unit vector. See, these are types of vectors. A vector, if it has magnitude 1, then such vector is known as a unit vector. Have you got it? If a vector has magnitude as 1, then such vector is known as a unit vector. Next, let us learn localized vector. Means if at least one of its end is fixed. At least, see how I am using, at least one of its ends is fixed means you may get like this. One of its end is fixed and other end is continuous. Otherwise, both ends are both ends are fixed. Let it be A, B, and this is OA. So this kind of vectors are known as localized vectors. See, observe this. One of its end is fixed at O and other end is continuous. We kept this arrow headed mark, which means it is continuous. Here two of its ends are fixed. So this kind of vectors are called localized vectors. If both ends are endless, then such vectors are known as free vectors. What we have to call them? Free vector. If both ends are endless, then such vector is known as a free vector. Now, I am giving you a vector A. I am asking you to find whose unit vector. So, unit vector is denoted by this symbol. You have to read it as A cap. A cap is equal to, vector A by mod A. So, this is a unit vector in the direction of a vector A. What it is? It is a unit vector which is in the direction of A. A by mod A. A is the given vector, and if you divide A with whose magnitude, then you will get whose unit vector, which is along with a vector A. And a unit vector which is opposite direction of A means, see, just here you would have to change the sign, minus A by mod A. This is also a unit vector which is in the opposite direction of A. You are having a negative sign now. See, now I am asking you to find a vector having magnitude m and which is in the direction of A. Find a vector having magnitude m in the direction of A, means here. So, m into A by mod A. If m is positive, then that vector is in the direction of A. If m is negative, that vector is in the opposite direction of A. What is this? It is a one vector having magnitude m and which is in the direction of A, m into A by mod A. See, two vectors A and B are called equal if and only if their magnitudes are equal. If their magnitudes are equal, then such vectors are called equal vectors. If their magnitudes are not equal, then such vectors are unequal vectors. Okay, got it? Right. Next, if two vectors, one is A and one more is B, if both are parallel and which will be in the same direction, then which will be called as like vectors. What do we say them? Like vectors. If both are parallel and which are there in opposite direction, then which will be called unlike vectors. Unlike vectors. Okay, students, if both are parallel and which will be in the same direction, then which will be called like vectors, and both are parallel and if there is two are in opposite direction, then which will be called unlike vectors. See students, next, Let us learn the vector component of a point P, which is given in the space. See here, this is x-axis, y-axis, z-axis. Now in the space there is a one point P whose coordinates are x comma y comma z. Now I am asking you to write vector component of OP. How do we write? So let us consider I is a one unit vector which acts along the positive direction of x-axis, and j is also a unit vector, means whose magnitude is 1, and acts along the positive direction of y, and this is along with positive direction of z-axis. Let it be k. Now you know coordinates of origin. To find the vector component of OP, find the drs of OP. Drs of OP, you know, x minus 0, y minus 0, z minus 0. After getting whose drs, and multiply this drs with I, j, k, so that you will get vector component of OP as xi plus yj plus zk. You can write it as OP bar. What it is? Vector component of OP, xi plus yj plus zk. How did I write? I took I, j, k are unit vectors which acts along the positive direction of x-axis, y-axis, z-axis respectively, and I prepared the drs of OP. I got x, y, z, and this drs of OP I multiplied with I, j, k, so that I got this. Like this you people have to generate vector component of a directed line segment. Okay students, right. Next, two position vectors are given like this. This is A bar, and B, whose position vector is B bar. And between AB there is a one point C, and C is dividing AB in the ratio m is to n. C is there inside of AB, hence m is positive and n is positive. Now I am asking you to find the position vector of C. Okay, find a position vector of C which divides position vector of A and B in the ratio m is to n. Simply you have to apply the section formula which you learnt in the introduction of two-dimensional geometry. So here C divides AB in the ratio of m is to n, no? Then as a position vector of C is equal to position vector of C is equal to m B bar plus n C A bar by m plus n. If C is exactly middle of AB, then m is to n is equal to 1 is to 1. You know that if you put m equal to 1, n equal to 1, then C coordinates will become A plus B by 2. You can write it as OC. This is OA. OA is equal to O bar, A bar, OB is equal to B bar. Now position vector of C is A plus B by 2 if C is exactly middle of AB. So this is called section formula. I hope you have got it. But every time C need not be inside. C may divides AB from external part. So in such case you get like this. C, here it is A, here it is B. Now C is there on the extension portion. So here OA, position vector of A bar position vector of B, B bar. And C is dividing AB in the ratio of M is to N, where M is positive, N is positive. Which means that CA by CB you have to find. So the position vector of OC is, same like previous section formula, but middle minus you will get. How do we get minus? Which you learnt in the 2D. So MB bar minus N A bar by M minus N. This is the external division formula. C is dividing AB in the ratio of M is to N from external part of AB, which means that CA by CB, which is equal to M by N. Okay, so in this case you have to apply this external division formula to find the position vector of C. When position vector of A and B are given, collect this A and B from there and substitute in this, so that you will get position vector of C. Okay, right. Next, find the centroid of a triangle whose position vectors of vertices are given. See, A, B, C, whose position vectors are given as A bar, B bar, C bar, and asking us to find whose centroid. Same like 2D. So in the 3D also you learnt. Okay, so here okay, what you have to write here? A bar plus B bar plus C bar by 3. This is the position vector of centroid of the triangle. So here A, B, C are 3 points in the space. If you connect them, you get a triangle, and they are asking us to find centroid of this triangle. So you would have to apply this formula. A bar plus B bar plus C bar by 3. Okay, in the 2D and in the 3D also you learnt this formula. And let us find centroid of a tetrahedron. Tetrahedron, it is a 3D figure which cannot draw on the board. So it will get 4 vertices. So 4 vertices of a tetrahedron will be given to you. A coordinates A bar, B is one more vertex whose position vector is B bar, and C bar, and D bar. These are the 4 vertices of a tetrahedron. Okay, and asking us to find whose centroid. So OG bar, which is equal to A bar plus B bar plus C bar plus D bar by 4. This is the position vector of whose centroid. What is this? Centroid of a tetrahedron. So centroid divides each median in the ratio of 3:1 in the tetrahedron, but whereas in the triangle, centroid divides each median in the ratio of 2:1. Remember that point also. Next, let us learn angle between the two vectors. See here, this is O, here A, and here it is B. Now this is theta. This theta can be 0 to 180 degrees. If exactly both are coincident, If both are coincident, then theta will be 0 degrees, or if both are in opposite direction, this is A, this is B. In this case, angle between them is 180 degrees. If both of them are 90 degrees to each other, this is A and this is B, then these two vectors are called orthogonal vectors. If angle between the two vectors is 90 degrees, then such vectors are called orthogonal vectors. Here, if both are coincident or both are parallel, then angle between them is equal to 0 degrees. If both are on the same line but which are moving in the opposite direction, OA is that side, OB is this side. So in this case, angle between two vectors is 180 degrees. See, one vector here, let it be A vector moving this side and B vector moving this side. Both are like vectors and both are parallel, or both may be collinear. In such case, you may get A is equal to some lambda into B bar, or you may get B is equal to some M into A bar, where M and lambda and M are scalars, means any real numbers. Both vectors are parallel or collinear, then you get A is equal to lambda B bar. A is lambda times of B, or B is M times of A. Remember this, very very important. Two vectors are parallel or collinear, then you have to apply this condition. See, suppose if you take a vector A like this, A1x, A1i plus B1j plus C1k, and one more vector B, see, A1, A2, A3, and one more vector B you can take like this, B1i, B2j, B3k. Both are collinear, means lying on the same straight line, or if both are parallel, then this corresponding coefficients will be proportional. A1 by A2, which is equal to B1 by B2, which is equal to C1 by C2. Remember this. If both vectors are parallel or collinear, then A1 by A2 is equal to B1 by B2 is equal to C1 by C2. I hope you have got it. Next, there is one plane. In the plane, there are two vectors, A and B. Both are non-zero vectors, non-collinear, non-parallel, and R is one vector. These three are coplanar. Coplanar means vectors which belongs to the same plane are known as coplanar vectors. Whenever these three are coplanar, and condition for these three are non-collinear and non-parallel vectors which belongs to the same plane. Hence, this R can be written as XA bar plus YB bar, where X comma Y are scalars and X and Y, both of them not equal to 0. X, Y not equal to 0. Remember this. So X equal to R equal to XA bar plus YB bar. X and Y are scalars, and simultaneously X and Y should not be equal to 0. Okay. So for this coplanar vectors, so you can write like this. Got it? Right. Next, here some n vectors are given like this: a1 comma a2 comma a3 and so on an. There are n vectors are given. These n vectors are linearly dependent. Linearly dependent if there exists a scalars x1, x2, x3 and so on xn, such that a1 x1 plus a2 x2 and so on an xn, which is equal to 0. These n vectors are linearly dependent if and only if there exists n scalars such that a1 into x1, a2 into x2 and so on an xn is equal to 0. I hope you have understood this. These are the vectors, these are the scalars. If you multiply respect to vector and scalar, vector and scalar, vector and scalar, and if you add them, then result would be 0. Then you can say that these given vectors are linearly dependent. Okay, students? And these are linearly, okay, here condition for the scalars is simultaneously all of them not equal to 0. Okay, at least one of these n scalars should not be equal to 0. That is the condition here. Okay, all these are linearly dependent. Whenever this a1 x1 plus a2 x2 and so on an xn equal to 0, where x1 x2 x3 and so on xn are scalars. And condition for the scalars, at least one of the scalar must be not equal to 0. And when you have to say these vectors are linearly independent, so same condition, but here all of them should be equal to 0. The scalars, all these n scalars must be equal to 0. Then this given vectors are called linearly independent. For the dependent, at least any one of the scalar must not be equal to 0. But if these are linearly, these vectors are linearly dependent, then at least one of the scalar must be not equal to 0. Okay, but if these are linearly independent, all the scalars must be equal to 0. Remember. Okay, I think no confusion in this linearly dependent and independent. Right. Next, actually when you go to the applications, they will give you three vectors like this: a vector a1i plus a2j plus a3k, and b vector b1i plus b2j plus b3k, and c vector c1i plus c2j plus c3k. And they will question you whether these are linearly dependent or independent. They may question you. Just you would have to prepare the determinant which forms by these coefficients a1, a2, a3, b1, b2, b3, c1, c2, c3. The determinant which forms by 3 by 3 matrix is equal to 0. Then these three vectors are linearly dependent. If the 3 by 3 det which forms by these three coefficients is equal to 0, then what you people have to comment on ABC? Which are linearly dependent. If this det is not equal to 0, then that vectors will be linearly independent. Linearly independent. Right. Next, See students, right, next, orthonormal vectors I comma j comma k are unit vectors which acts along the positive direction of x-axis, y-axis, z-axis. Okay, angle between I comma j or j comma k or k comma I is 90 degrees because which are acting along with the positive direction of x, y, z axis. So in this coordinate system, angle between x-axis and y-axis is 90, y-axis and z-axis is 90, z-axis and x-axis also 90. Hence, ijk are orthonormal vectors because angle between ij or jk or ki is 90 degrees. Hence, which will be called orthonormal vectors. Okay, right. Next, there is a one vector which is passing through A and parallel to a vector B. This is B vector and this is our required vector which is passing through A. Now I am asking you to find our required vector equation. Find the equation of vector A which is passing through A bar and parallel to B bar. How do we find means? Just to take a resultant vector R. Okay. So R minus A. Both are parallel to each other. Na? R minus A equal to T into B bar you can take. Because both are parallel. Whenever those two are parallel, as I said to you. So this vector is T times of B. Where T is a scalar. T is called what? A scalar. When you transfer A to the right side, R equal to A plus TB bar, where T belongs to any real numbers. So this is the equation of a vector passing through A and parallel to B. Okay, students? Right. Remember like a standard result. So equation of a vector passing through A and parallel to B means you have to apply this formula R equal to A and plus TB bar where T is any scalar. So this A and B will be given. So bring those two vectors and substitute here and go for simplification. Otherwise leave like that. So this result will be called vector equation of this vector which is passing through A and parallel to B. Next, find the vector equation which is passing through two vectors A and B. A and B. So in such case you have to write this formula R equal to 1 minus T into A bar plus TB bar. This is the required vector equation which is passing through 2 points A and B. 2 points on the required vector will be given to you and they will question you to find equation of that vector. In such case apply this formula R equal to 1 minus T into A bar plus TB bar. Okay, right. Next, one more question. See, find the equation of a vector passes through origin and parallel to a vector B. Means in the previous one, R equal to A plus TB bar. I said to you this formula, no? Passes through origin means put A equal to origin. So that you will get 0 plus TB bar. So this is our required vector equation which passes through the origin and parallel to a vector B where T is a scalar. And find the equation of a vector which is passing through A and parallel to B and C. So in this case same like previous one. So take any resultant vector here or R minus A bar which is equal to TB bar and SC bar where T and S are any scalars. Because this is our required vector which is passing through A bar and it is parallel to B and C. So use this formula. Transfer A to the right side. A plus TB bar plus SC bar. This is our vector equation. Required vector equation. Now find the equation of a vector which is passes through 3 points A, B, C. A, B, C. A, B, C. 3 are given. Then use this formula. R is equal to 1 minus T minus S into A bar plus TB bar SC bar. Okay students, this is the equation of a vector which is passes through A, B, C vectors. R is equal to 1 minus T minus S into A bar plus TB bar plus SC bar, where T and S are scalars which belongs to the real numbers. Okay? Right. Next students, see, let us learn triangle law of addition and parallelogram law of addition. See, the triangle law of addition. This is ABC. ABC is a triangle, and AB vector and BC vector. AB vector is given as A bar and BC vector is given as B bar, and asking us to find AC bar, vector AC. Now vector AC can be written as AB plus BC. AB plus BC. So this is known as triangle law of addition. What is this? Triangle law of addition. This AC can be written as AB plus BC. If you want, you can express as a position vector. If AB is given, then what you have to write? OB minus OA. OB minus OA, and BC you have to write OC minus OB. Now plus OB minus OB cancel, OC minus OA. It can be written as AC. Okay students. Now this is known as a triangle law of addition. This is very, very important. So now AB. AC vector you would have to find. AB vector is given as A bar, BC vector is given as B bar. This direction is very, very important. AB plus BC, which is equal to AC. Next, let us go to the parallelogram law of addition. See, this is one parallelogram, OA, BC. Now OA vector is given as A bar, OC vector is given as B bar. Then this diagonal OB is the sum of these two vectors, A bar plus B bar. How we will get? By the triangle law of addition only, because in a parallelogram these opposite sides are parallel. It is given as B bar, no? Hence that B bar can be written for AB because both are parallel. Now I want OB. How do I get OB? By adding these two, by the triangle law of addition. So then OB is equal to A bar plus B bar. Okay? Right. Next. If I ask you this CA. How do you find CA? Here OB and CA are both diagonals. So now OA is A bar and BC you can write minus A bar. Am I right? Because OB is acting this side, then BC is acting this side. Both are parallel and in opposite direction. So that BC is represented with minus A bar. Got my point? Now find CA. Find, sir, what I want? AC. What I want, amma? AC. AC is equal to AB plus BC. AB plus BC you can write now. Here OB minus OA, OC minus OB. Both will be cancelled. Then OC minus AC equal to AC you can write. So then AC is equal to sum of these two. B bar minus A bar. Okay. If two vectors OA and OB are given, both are having common initial point. Vectors having common initial point, then which will be called co-initial vectors. If the vectors having same end point, then which will be called co-terminal vectors. You know this. So here in this, adjacent sides of a parallelogram are given and asking us to find whose diagonals. In such case, you apply this formula. A bar plus B bar and B bar minus A bar. And sometimes diagonal equations will be given to you and they will ask you to find side vectors. Diagonal vectors will be given. And what do they ask you? Sides means OA and AC you would have to find. In such case, simply you have to solve it. So if you add them, both of them cancel. So what do you get? OB plus AC, which is equal to 2B bar. Now B bar is equal to OB plus AC by 2. Okay students, whenever the diagonal equations are given, and how do you get B? OB plus AC by 2. So that you will get this B vector, that is OC. And if you take the subtraction of these two, what do you get? AC is equal to subtraction. If you go for subtraction of these two, A bar plus B bar and AC, B minus A. So minus minus plus, both of them cancel. OB minus AC, which is equal to 2OA. So now A is equal to OB minus AC by 2. Okay students, here two types of questions can be expected. Whenever the adjacent sides of the parallelogram are given and find the vectors of whose diagonal. In such case, simply you have to add A plus B and B minus A. If you add A plus B, you will get OB vector. If you go for B minus A, you will get AC vector, B minus A. But what is second question? Diagonal vectors will be given, OB and AC, and they will ask you to find other side vectors. Means you have to find A and B. If you know A and B, you can find this AB and BC vector also. Once you see the board, I hope you have got it. Right? Next, now I am going to find angular bisectors. See, this is O, this is A, and this is B. Now OA vector is given and OB vector is given. And whose interior angle bisector, they will ask you. Interior angle bisector, you know, which divides this angle into two equal halves. Interior angle bisector. Interior angle bisector of AOB. Interior angle bisector of AOB, which is equal to lambda into A by mod A plus B by mod B, where lambda is any scalar, means real number. So sometimes they may ask you this exterior angle bisector. This is exterior angle. Whose bisector means you have to extend this side. Okay. So this is the exterior angle bisector and this is the interior angle bisector. If you apply this formula, you will get interior angle bisector. lambda into a by mod a plus b by mod b. For exterior angle bisector, in the middle you have to take minus. Exterior angle bisector, which is equal to lambda into a by mod a, b by mod b. Okay students, for the interior angle bisector here you will get my plus, and for exterior angle bisector here you will get minus. So these are the important conceptual points which are related to the addition of vectors. I hope you have understood my class. Thank you one and all.